Many naturally occurring phenomena can be described by normal curves, or approximately normal distributions. The standard normal curve has a mean of 0 and a standard deviation of 1. And we want to use z-scores to find areas under the curve. We had done this once before using the empirical rule. And one of the things the empirical rule said was that 68% of the area fell between one standard deviation below the mean and one standard deviation above the mean. That's an example of what we're talking about here. But we want to be able to find an area from any z-score to any other z-score, not just -1 to 1 and not just -2 to 2. We want to use decimals as well. Okay, so we're going to use a table for this. And also we can use technology such as calculator or web apps to find areas. Let's do it with the table first. There's a reference sheet here that tells us the relationship between the z's and the areas. So in this table, you have to find your z-scores on the left column, and then your areas will be in this big section here. There's actually two versions of the table though. There's one for negative z-scores, and then there's one down here for positive z-scores. The first one we're asked to find is the cumulative area corresponding to a z-score of 0. So we want to find the z that we're interested in, and then the number next to it here will be the area. Now that should make sense according to the fact that this table is designed to give you areas to the left of the z. So here's a z of 0. If you want to know the area to the left of the z, you'd shade all this, which is actually half of the normal curve. And that's why the answer is 0.5. So that was supposed to be an easy one to start with. The cumulative area that corresponds to a z of 0 is 0.5. Now whenever it says cumulative area, we just assume that it's talking about the left side, the left tail. So you start all the way over here, and you shade it in until you get to the boundary, the cutoff of the z that they're talking about. Next question asks us, what's the cumulative area that corresponds to a z of 1? So we actually want to move our boundary now from here over to here. It's obviously going to be more area. It's going to be all this. But that's what the table is for, is to tell us the area to the left of a z of 1. So let's check it out. Here's our z of 1. You find the z's below the z heading. And then the area is in this section. So 0.8413. How about the area to the left of a z-score of 2? Move our boundary. Shade all the way over to here. It's almost all the area. All the area under the curve is 1. Let's see what this one ends up being. There's our 2. Our area will be 0.9772. And how about the area to the left of a z of 3? That's not even on the picture above, but it is on the table. It's right here. 0.9987. Now when we do the negatives, we want to use the other chart. This one is for areas that are 0.5 or greater. So we'll scroll here to the other chart. This one's for negative z's. So we look for -2. That's right here. But the way that the table is organized here is they wanted to condense a lot of information into a small space. And we want to be able to look up z's that are a little more precise than just the 10th place. Sometimes we want to look for a 100th place too. So let's say that the z we're looking up right now is -2.00. The hundredths of the z are located up here on this top row here. So you actually have to, in this particular case, notice that the 0/100th is actually on the right side. See, if you would go with the one right next to it, that's actually got a 100th of 9. That would be -2.09, which you don't want. We want -2.00. So what we'll do is we'll actually just trace that down in that column and then trace our row over here to see where the 2 intersect. So you see what I'm doing there? You trace this over and then you trace this down. You got to intersect them. So it's 0.0228. Small area because we're talking about just the left tail from here on over. 0.0228. Okay. How about the area to the left of -3? That's going to be even less. Okay, now we need to find the -3. We got to trace it all the way over. Intersect them. We're looking at 0.0013. Cumulative area corresponding to 0.5. Let's go back to our positive side now. 0.5 is right here. In this case, since our 100th is just going to be a 0, and this is the 0 heading here, we can just take this one right here. 0.6915. Here we want 1.15. It's got a 100th. A 100th that's not 0. How do you do that? Well, we're looking for 1.15 as a z. So we do the best we can. We look up 1.1 first. Okay? Then we have to go to the hundredths on top. And we want to look for 5/100ths. Trace that down, that column. Trace this row over. and you actually put the 0.05 onto the 1.1 to make 1.15. So it's 0.8749. Okay, in all those cases, we were given a z-score, and we were asked to find the area. So we went from z to area. What we want to do down here with these problems is the reverse. We want to start with the area and go to a z-score. And whenever you're using that table, you always want to think very carefully about what am I being given and what am I asked to find. If I'm being given a z, then I need to look it up on the left column, and then I find my answer in the area space. But in these problems, I'm being given an area, and they're asking me for a z. So I'm actually going to start in this body of the thing right here, the area section, and I'll find the z from that. Alright, let's try one like that. This one says, find the z-score that corresponds to an area of 0.5. Okay, so that's an easy one to start off with. The area is assumed to be a left tail unless otherwise specified. So if they talk about 0.5, they're talking about half the normal curve. And they're saying what z-score now corresponds to it. Well, it's going to be a z of 0. But let's see if we can find that from the table. So go to the table. You want to search in this big section here for a 0.5. I see it right here. And now you want to use the z of the row that it's in. And you could also attach the hundredth to it. In this case, though, they're just talking about a z of 0. 0.00. Okay, that one wasn't too bad. Now let's find the z-score that corresponds to an area of 0.0281. Okay, so these z's are positive, and the areas are actually all greater than 0.5. So if we need 0.0281, we're actually going to have to go to the other table. Okay. So look in the body of the table. Look for a 0.0281 if you can find it. Okay, I think I see it right here. Yep. 0.0281. You got to see what row it's in. So negative 1.9. But you're not necessarily done yet because you got to find out what column it's in too. It's in the 0.01 column. So you got to add that 0.01 to your negative 1.9. You get the final answer, negative 1.91. That's the z-score of that area. So we'll write that in. Okay. Now there's another rule that says if your area is not in the table, just use the closest entry to the area. Alright, let's check out 0.68. That's going to be on the positive z side. So let's go down there. Do we see 0.068? I'm sorry, 0.68. Okay, there's one candidate here. It's pretty close to it. And there's another candidate here that's quite close to 0.68 as well. So our entry is not exactly on the table. We're looking for 0.68. So the one on the right is 8 ten-thousandths off. We could actually just subtract them to find that difference. 8 ten-thousandths off. That's not very far away at all. If you subtract these two, though, you'll get 28 ten-thousandths. So we want to actually go with the one that's closer. That would be the 0.6808. So find out what row he's in, find out what column it's in, and then just add them together. 0.4 plus 0.07 makes 0.47. Okay. Another thing that might come up is you might find that the area you're asked to find is halfway between two entries, like exactly halfway. So I'll do just one more as an example of that. What if you're asked to find the area of 0.95? So look for 0.95 in the table. You'll see that it's close to these two entries. It's actually equally close to both of them. It's 5 ten-thousandths away from both of them. So it's like, which one do we use? We see that the row it's in is 1.6. So the possibilities are maybe the z should be 1.64 or maybe it should be 1.65. When that happens, what we want to do is actually average them. Add them up and then divide by 2. So that for an area of 0.95, z equals 1.645, halfway between the two.